Hi all. My seminar topic is Overview of Expert System Technology. So, an expert system are a type of artificial intelligence that emulates the decision-making ability of a human expert. They are designed to solve complex problems by reasoning through knowledge and providing solutions based on that knowledge. The expert system are usually intended to complement, not replace, human experts. In the year of 1917, the first expert system was developed, which was the first successful approach of artificial intelligence. It is one of the prominent research domains of artificial intelligence, and one of the common example of expert system is suggesting a spelling errors while typing in the Google search box. So basically the expert system is nothing but it's a computer application to solve the complex problem in a particular domain at the level of extraordinary human intelligence and expertise. Now let's see the characteristics of expert system. The expert system have high performance and understandable, reliable, highly responsive, adequate response time, and use symbolic representations. The expert system provides high performance for solving any type of complex problem of a specific domain with high efficiency and accuracy. So we can say that expert system have high performance. Understandable means it responds in a way that can be easily understandable by the user. It can take input in human language and provides the output in the same way. It is much reliable for generating an efficient and accurate output. That means it is reliable also. Highly responsive refers expert system provides the result for any complex query within a very short period of time. And adequate response time. The system should be designed in such a way that it is able to perform within a small amount of time, comparable to or better than the time taken by a human expert to reach at the decision point. And at last, to use symbolic representation for knowledge and perform their inference through symbolic computation that closely resemble manipulations of natural language. Next is capabilities of expert system. Advising. It is capable of advising the human being for the query of any domain from the particular expert system. It provides decision making capabilities. And demonstrative device, that is, it is capable of demonstrating any new product such as its features, specification, how to use that product, etc. It has also the capabilities to solve a problem and explaining a problem. It is also capable of providing a detailed description of an input problem. Interpreting the input means it is capable of interpreting the input given by the user, and it can also the capabilities of predicting the result, or it can use to predict the result. Diagnosis. An expert system designed for the medical field is capable of diagnosing a disease without using multiple components as it already contains various inbuilt medical tools. Next, we can introduce the components of expert system. It has mainly three components. Apart from this, it has two modules also, which are named as knowledge acquisition and learning module and explanation module. The knowledge acquisition and learning module is a component function to allow the expert system to acquire more data from various sources and store it in the knowledge base. The explanation module, as the name suggests, it helps in providing the user with an explanation of the achieved conclusion. The main three components are knowledge base, inference engine, and user interface. The knowledge base represents fact and rules. That is, it contains knowledge in specific domains along with the rules in order to solve problems and form procedures that are relevant to the domain. Next is inference engine. The most basic function of the inference engine is to acquire relevant data from the knowledge base, interpret it, and find a solution to the user's problem. Inference engine also have explanatory and debugging abilities. The last is user interface. The non-expert user interact with the expert system and find solution through the user interface. From this, we can understood that the inference engine acts as a brain of the system. This component have two strategies for acquiring knowledge from the knowledge base, namely backward chaining and forward chaining. So, a forward chaining is used to answer the question what will happen next. This strategy is mostly used for managing tasks like creating a conclusion, result, or effect. Predicting or share market movement status is an example of forward chaining. Next, backward chaining. Backward chaining is a strategy used by the expert system to answer the question why this has happened. So, this strategy is mostly used to find out the root cause or reason behind it, considering what has already happened. An example of this is diagnosis of stomach pain, blood cancer, or dengue, etc. Next, we can know about the advantages and disadvantages of expert system. So it have many advantages like this system are highly reproducible. They can be used for risky places where the human presence is not safe. Error possibilities are less in knowledge base contains correct knowledge. The performance of this system remains steady as it not affected by emotions, tensions or fatigue, and they provide a very high speed to respond to a particular query. Although it has many advantages, it has some disadvantages also. These are the response of the expert system may get wrong if the knowledge base contains the wrong information. Like a human being, it cannot produce a creative output for different scenarios. Its maintenance and development costs are very high. Knowledge acquisition for designing is much difficult, and one of the big limitation was each domain we require a specific expert system. And last, it cannot learn from itself and hence requires manual updates. Nowadays, many areas use this expert system for the purpose, mainly in designing and manufacturing domain. It can be broadly used for designing and manufacturing physical devices such as camera, lenses, and automobiles. In knowledge domain, primarily used for publishing the relevant knowledge to the user. The two popular expert systems used for this domain is an advisor and a tax advisor. In finance domains also, the expert system are used. The diagnosis and troubleshooting of device. In medical diagnosis, the expert system is used and it was the first area where this system were used. Planning and scheduling. The expert system can also be used for planning and scheduling some particular task for achieving the goal of that task. Somehow, it also used for language translation. That is, it is designed to translate language by applying linguistic rules. Now, there are mainly three types of expert system: rule-based system, fuzzy expert system, neural network expert system. Rule-based system are use a set of explicitly defined rules to make decisions or solve problems. By taking an example, we can say that an expert system for diagnosing computer hardware issues might have rules like if the computer does not power on, then check the power supply. And the fuzzy expert system handle uncertainty and imprecision in data by using fuzzy logic. The example of a fuzzy expert system is temperature control in a room might use rules like if the temperature is moderately high, then slightly reduce the air conditioning. Last is neural network expert system. As the name suggests, it use artificial neural networks to emulate the human brain's pattern recognition and learning capabilities. An expert system for image recognition might use a neural network to identify objects or people in images. It's an example of neural network expert system. Now we can see the several examples of expert system. Dentrel. It was an artificial intelligence product that was made as a chemical analysis expert system. It was used in organic chemistry to detect unknown organic molecules with the help of their mass spectra and knowledge base of chemistry. Next, mycin. It was one of the earliest backward chaining experts. We already say that what is backward chaining. It was also used for the recommendation of antibiotics and the diagnosis of blood clotting disease. Next, it's an expert system that is used to determine the type and level of lung cancer. To determine the disease, it takes the picture from the upper body, which looks like the shadow. This shadow identifies the type and degree of harm. And last is CADET. The CADET expert system is a diagnosis support system that can detect the cancer at early stages.